गुड इवनिंग एवरीवन, वेलकम टू बायजूस एग्जाम प्रेप। सो आज हम लोग यहाँ पे स्टार्ट करने वाले हैं फंडामेंटल्स ऑफ ईएमएफटी, जिसका सेकेंड लेक्चर वी आर कंटिन्यूइंग, दैट इज आवर कोऑर्डिनेट सिस्टम. So in the last lecture we discussed about the different type of vectors and what are the vector products. So the voice is absolutely clear. Yes, good evening Sagnika. How are you? And I hope that you have watched the previous lecture also. So in the last lecture we discussed about the vectors and the scalar. How do we define the vectors and the scalars? What are the vector addition and how do we perform the vector products? That is the scalar product and the vector product, right? So now we are going into the next topic, which is the coordinate system. So from here actually basics of EMFT starts. So let's start the session, and before starting the session, let me introduce myself. If you are not aware about myself, then this is Saket Verma, and I am having more than 12-year experience in the field of teaching. So I have taught in the different platforms, and presently in the last 2 years I am working with BYJU'S in this platform, which is the most comprehensive preparation platform. And I have cracked different PSU exam as well, and I have mentored more than lakhs of students in the last 12 years. So now if I talk about my area of expertise, then EMFT and communication system, advanced communication system, and signals and system, and ICT. These all are my area of expertise where you can get the clarity from me, and you will get the good command if you get content from my side. If you attend my classes, then I will make sure that you will attend maximum out of it. Okay, now let's directly jump into the topic, which is our coordinate system. So when we compare with the coordinate system, there are three type of coordinate system. Basically, the first coordinate system is your Cartesian coordinate system, right? So this is the Cartesian coordinate system. So when we talk about the example of the Cartesian coordinate system, you can take this as a coordinate. This is what a example of coordinate system. Okay, this is the Cartesian coordinate system. Now, if I talk about the cylindrical coordinate system, then the cylindrical coordinate system can be compared with the coaxial cable. Okay, so you can compare the cylindrical coordinate system with any cylindrical shape, like a bottle also you can consider, which is having the shape of cylinder. Now the third coordinate system is spherical coordinate system. So in the spherical coordinate system, you can compare this with a football. Okay. So in this way, we have the three different coordinate system, and one by one we will discuss the coordinate system and their relationship with each other in the today's session. Okay, Sagnika. So first of all, once comment me so that I will come to know that how many of you are actually watching live, so that I will ask the question from you guys. Okay. And from the Cartesian coordinate system, we generally study the right hand coordinate system, which always follows the right hand rule. What is the right hand rule? The right hand rule which we studied in the last lecture, that is when we take the cross product of the vectors in the anti-clockwise direction, then it is called as a Cartesian coordinate system, or the right hand rule. So right hand rule means we are going to follow the anti-clockwise direction. So if suppose I will give you this axis x and then this is y, then by this particular rule of anti-clockwise cross product of unit vectors, you can tell the third axis also. If you curl your finger from x-axis to y-axis, then that thumb will be pointing in the positive z direction, because we are moving in the anti-clockwise direction. According to this rule, AX cross AY, we get AZ, right? So when you take the cross product of AX and AY, you get AZ. Similarly, when you curve your finger from x-axis to y-axis, then the thumb in which it will point will become your z-axis. Yes. Okay. Now, similarly, right, if I want to ask you about this, now tell me where will be the third axis? Okay. What will be the third axis? Please tell me. If suppose this is y and this is z, then in which direction you will say x coordinate? X coordinate will be there in which direction? Whether it will be the outside the board or inside the board or inside the paper. When it is y-axis and the z-axis, then in which direction you will get the x-axis? Positive or negative, in which direction? Okay, so if I say this, then when I curve my right hand finger from y-axis to z-axis, if I curve my finger from y-axis to z-axis, then it is going inside. It is going inside. That means my x-axis is inside the screen. So my x-axis will be inside the screen, and outside the screen we have minus x-axis. Obviously, because we are actually moving in the clockwise rotation, so when we move in the clockwise direction into the paper, positive x-axis. Very good. So that will be the direction, and this is how we calculate the direction of third coordinate. So this is the right hand convention, that if it is x, then it is y. Then if I curve from x to y, we will get z. And if suppose this is x, this is y, if I curve my right hand fingers from x to y, I will get z in this direction. If you curve your right hand finger, that is your upward direction x, and the y is this direction. So when you curve the finger from x to y, the thumb is pointing in the z direction. Okay. Yes. Now, what is the how do you represent the vector in the Cartesian coordinate system? So, whenever you want to represent the vector in the Cartesian coordinate system, you should have the three components. One magnitude is in the x direction, another magnitude is in the y direction, and the last one is in the z direction. It may have some component, it may not have the component, but in general we will say, let us suppose the all the a vector is having all the three components x, y, and z. So ax into ax cap plus ay into ay cap plus az into az cap. Okay. So now coming to the cylindrical coordinate system, but before going into the cylindrical coordinate system, what is the range of x, y, and z? What is the range of x, y, and z in the Cartesian coordinate system to cover the entire space, in the form of the shape I told you, that is cuboid, you can say, is having the range from minus infinite to infinite. Okay, that is the range. That is the range of the coordinates x, y, and z, ranging from minus infinite to infinite. So this is the range of parameter, right? So what are the three parameters we have in the Cartesian coordinate system? In the Cartesian coordinate system, we have the three parameter x, y, and z. What are the unit vectors we have? The unit vectors are ax, ay, and az. And all these three unit vectors are which nature? They are orthogonal in nature. Okay, they are orthogonal in nature. They are orthogonal in nature. Correct? That is, what do you mean by orthogonal? That is, if you take the dot product between the two unit vectors, you will get the value 0, right? And how do we represent a vector in the Cartesian coordinate system? So to represent a vector in the Cartesian coordinate system, we need a three components: ax, ay, and az, and their unit vector. In general, we can have all the three direction, and but in the practice, we can have any one component or two component absent also. Yes. Now, coming to the cylindrical coordinate system, in the cylindrical coordinate system, we will have the cylindrical shape. Suppose this is x-axis, this is y-axis, and this is z-axis. Then, any distance measuring from the z-axis, any distance measuring from the z-axis is known as the radius. Any distance measuring from the z-axis is known as the radius of the cylinder, and angle measured from the x-axis is known as the azimuthal angle. So angle measured from the x-axis. Remember that we always measure the angle from the x-axis in the anti-clockwise direction. Then it is known as azimuthal angle. And any distance measured from the z-axis is known as radius of the sphere, and the z is the vertical distance. Whenever you want to cover in the vertical distance, then in the cylindrical coordinate system we represent it by z. So what are the range? The range of the parameters are 0 to infinite. Okay, it may be 0 to infinity, it may be 0 to infinity, and then find what is the angle required to make the complete circle. To make the complete circle, we require an angle of 0 to 2 pi. And what is the length which we want to cover in the z-axis? We want to cover the entire space. So that is minus infinite to infinite. Yes, absolutely fine. Okay, so this is the range that you should know. And if I ask you what is the rho, then don't call it as a radius of the cylinder. Basically, if you will remember this, the rho is defined as the distance. It is defined as the distance measured from z-axis, then you will never get confused. And phi is the angle measured from x-axis. In which plane? In xy plane only. In xy plane only. We actually measure the angle where this bottle is placed. Suppose you are putting one cylinder and you are putting the cylinder on the floor, then you measure the angle on the cylinder on the floor. Okay, that angle is measured on the floor, or that is also known as azimuthal angle. That is also known as azimuthal angle, and z is the simple distance which we measured in the vertical direction. Okay, now what is the relationship between the cylindrical coordinate system and the Cartesian coordinate system? Suppose we have the three coordinates x, y, and z, that is the parameter of Cartesian coordinate system. Let us suppose the distance measured from the z-axis is rho. This is our cylindrical coordinate system parameter, and the angle measured from x-axis is phi. So this is the angle measured from the x-axis in the anti-clockwise direction, and this vertical distance is z. So to reach to this particular point P, we are actually moving in this three direction. The rho phi is that this point P is on the cylinder. This point P that I mentioned here is nothing but this point. So to reach to this point P, we are moving from O to A. That is, we are moving in the, actually I should write like this, O to A. That means this radius we are moving, and then we are moving phi angle. So we have reached to this point A dash, and after this A dash I am reaching to the point P. So I am moving from O to A to A dash, and A dash to P. That means I am moving in the three different direction and having the three different magnitude, that is rho, phi, and z. So in this way, I am representing a point in the space which is related to the cylindrical coordinate system, and this is x, y, and z, which is related to the Cartesian coordinate system. So now let's draw the perpendicular line from point P to the z-axis. So if I draw the line from point P to the z-axis, it is also showing the perpendicular distance. Okay, it is also showing this is also perpendicular. So this is also perpendicular. Now this vertical length is z, so this will also be z because you are drawing the perpendicular line. And when we are drawing the perpendicular line to this xy plane, this point is, let us suppose, p dash. Then what is we are doing? We are drawing the perpendicular line to the y-axis, and we are calling it as n. And we are also drawing the perpendicular line from point p dash to the x-axis. We are calling it as a M. So when we draw the perpendicular line from the point P dash to the x-axis, the distance measured with respect to origin is, because it is in the direction of x, we are calling it as a x. And because we are moving in the y direction, we are calling it as a y. So now we have three different coordinates. This is x, which is related to the Cartesian. This is y, which is again related to the Cartesian, and this is z, which is again related to the Cartesian. So these x, y, z, which I have circled, are the parameter related to the Cartesian coordinate system. Right now, at point P, we have a rho phi z, and these rho phi z are parameter which are related to the cylindrical coordinate system. Is it clear up to this point? Now, okay, now suppose I take the cos phi. Okay, if I calculate the angle cos phi in this particular triangle OMP dash, OMP dash, if I calculate the cos phi, this cos phi is nothing but a x upon rho. Isn't it? X upon rho. So we can call x as a rho cos phi. X is nothing but a cos component of rho cos phi. Similarly, if I calculate the sine phi in the same triangle, then it is height upon hypotenuse, that is y, upon hypotenuse, that is rho. So we are getting y is equal to rho sine phi. So this is the first equation we are getting. This is the second equation we are getting. Now if I compare both z, the z in the cylindrical coordinate system and z in the Cartesian coordinate system, both are symmetrical and identical. So this is z is equal to z. So what you are getting here, x is equal to rho cos phi, y is equal to rho sin phi, and z is equal to z. That means if you know the parameters in the cylindrical coordinate system, then you can convert it into the Cartesian coordinate system by using these three relations. Okay. Now, if I want to calculate x rho cos phi, if I want to calculate rho phi z, then this rho will be, if I add equation number 1 and 2, after squaring, I will get x square plus y square and root over it. This is equation number 4. And if I divide equation number 2 by 1, then I will get phi is equal to tan inverse of y by x. Okay, this is 5, and the z is still same. So if I give you the value of x, y, z in the Cartesian coordinate system, then you can calculate the coordinates in the cylindrical coordinate system. Is it clear? So these 6 equations are clear, and that is important for your exam point of view. Whenever you need to convert, you have to use this equation. So this is the relation. So relationship between the Cartesian and the cylindrical coordinate system we have already written over here. And then coming to the spherical, before going into the spherical coordinate system, what you can do is you can also convert the vector. You can also convert the vector which is given in the cylindrical coordinate system, and you can write the vectors in the Cartesian coordinate system. So to write the vector, what you need? To write the vector, any vector, you need the x component, and you will multiply with unit vector. You will need a y component, and you will multiply with unit vector, and you need a z component, and then you will multiply with the unit vector. Correct? This is the way you will write the unit vectors. So that means to write any unit vector, we need these coefficient. ठीक है, वी नीड दिस कोफिशिएंट एक्स वाई एंड जेड, ये कोफिशिएंट आपको चाहिए अगर आप कोई वेक्टर को लिखना चाहते हो, राइट। आपको यूनिट वेक्टर तो पता ही रहेगा, आपको एक्स कंपोनेंट, वाई कंपोनेंट और जेड कंपोनेंट चाहिए, उसके कोफिशिएंट चाहिए, फिर आप यूनिट वेक्टर से तो सिंपली मल्टीप्लाई कर लोगे, राइट। तो इसके लिए आपको मान लो मैंने दे दिया ए रो, ए पाई और ए जेड, मतलब if I give you the vector in the cylindrical coordinate system and I ask you to write in the Cartesian coordinate system, then how will you write? You can use this matrix. So this is cos phi, sin phi and 0, and this is minus sin phi and cos phi and 0, and this is 0 0 और 1. So अगर आप ये मैट्रिक्स यूज करते हो तो आप किसी भी सिलेंड्रिकल कोऑर्डिनेट सिस्टम के वेक्टर को कार्टेशियन कोऑर्डिनेट सिस्टम में कन्वर्ट कर सकते हो, करेक्ट। सिमिलरली आप इसका रिवर्स भी कर सकते हो। अब आपके मन में एक क्वेश्चन आएगा कि सर अगर मुझे ए रो, ए फाई और ए जेड इफ आई वांट टू कैलकुलेट, if I want to calculate a row, a phi and a z, then how will I calculate? So I will say don't do anything, just make the just write the transpose of this matrix. So the transpose of this matrix is cos phi minus sin phi and 0, and this is sin phi and cos phi and 0, and this is 0 0 and 1, and it is ax, ay and bz. So using this relation, so there are two relations, right? This is first relation, this is second relation. Whatever is required, you can use that particular matrix. Now coming to the spherical coordinate system, to understand the spherical coordinate system, you just compare it with the sphere. That sphere is nothing but a football. So how you are in the center of the football, if you want to reach to the surface of the football, then what you will do, you will move away from the center. So whenever you move away from the center, the radius will increase. So that means the r is required, that is the radius is required. So when you want to move in the surface of the football, suppose you want to move in this direction on the surface of the football, that means you have to rotate 360 degree. So that means phi is required. And similarly, when you want to move from vertical to horizontal, that means this is the north pole and this is the south pole. So because you were rotating in this direction, so it requires 360-degree angle, but now you want to cover from north to south, so that means you need a 180-degree change. So that means whenever you are representing a sphere, you need the three parameters. They are r, theta and phi. So what is r? So first of all, you need a radius. So you are moving in this direction. Okay, you are moving in this direction. That is your z-axis. So in any direction you can move. So whenever you move away from the center, it is radius. So this is we are representing as a radius. Okay, this point P we are representing because you are moving away from the origin. This is the radius r. And when you measure the angle with respect to the z, when you angle the measure with respect to z, then it is called a angle theta, and this angle phi is same. So r is known as radius of sphere. Okay, r is known as radius of sphere, and theta is known as angle. Always remember that this is angle measured from z-axis. So you have to measure the angle from the z-axis, and when you will measure the angle from the x-axis, then angle measured from x-axis, when you will measure the angle from the x-axis, it is called as the azimuthal angle, which is phi. So again here also there are three parameters required, and what are the range of these three parameters? So the range of these three parameters are r is equal to 0 to infinite, theta is equal to 0 to pi, and phi is equal to 0 to 2 pi. So this is the range that you should remember. So the range of all the three parameters you should remember. Okay, the range of all the three parameters in the three coordinate system you have to remember because it is important. Because actually I am only telling the range, I am not going into the detail because we want to focus only on the topic which are important for the exam point of view. So this particular coordinate systems, that much is only sufficient to solve any problem according to the GATE examination. You are not going to solve the conventional question, right? Now, yes. The range we have already got understood that r theta and phi. And now coming into this particular part, how do you find the relationship between these two? So the relationship is again very simple. This is x-axis, this is y-axis, and this is z-axis. This is the center. You will have to have this angle phi. This angle is theta. This distance is r because this is r, theta, and phi. Right? When you draw the perpendicular line, you will get in this point p dash. So this is nothing but a rho. The rho is nothing but the distance measured from the z-axis. So you are moving away from the z-axis. So you will call it as a rho. But this rho in and this rho both are same, and this is the vertical distance. So this vertical distance and this vertical distance, right? Now when I draw the perpendicular line, I am calling it as the m and n. I am calling it as the m and n. So this is nothing but a x, this is nothing but a y, correct? And this vertical distance is nothing but a z, right? So the x is, we have already calculated, this is rho cos phi. Now what is the value of rho? That is important. Now come to this particular triangle OPQ. Okay, come to in this triangle OPQ, in this triangle OPQ, when I will write cos theta. If I write the cos theta, then this is the base, this is the 90 degree. Na? So this is the 90 degree, so this is the base and this is the hypotenuse, so this is z upon r. So we can say that the z is equal to r cos theta. But when I will write the sine theta, that is the height which is rho and hypotenuse is z, so I can say that the rho is z sine theta. So that means rho is equal to, sorry, that is r. Rho upon hypotenuse is r. So this is rho upon r. So rho is equal to r sin theta. So z is equal to r cos theta and rho is equal to r sin theta. So from here we can say that x is equal to r sin theta, which is the value of rho, and then cos phi. So this is equation number 1, and y is rho sin phi, right? Rho sin phi. So y will become r sin theta sin phi, equation number 2, and the z is equal to r cos theta. We have already calculated, so this is equation number 3. So these are the three equations. Okay, these are the three equations like we calculated in the cylindrical and the Cartesian coordinate system. Correct? करेक्ट ओके नाउ जस्ट डू द रिवर्स थिंग है ना अगर आपको मान लो मैं बोल दूं कि आर थीटा और फाई में दे रहा हूं और नाउ कैलकुलेट सॉरी व्हाट इज द yeah now if I give you r सपोज मैं आपको दे दिया आर थीटा और फाई एंड आई विल आस्क यू टू कैलकुलेट x, then you will calculate in by using this equation 1 2 and 3, and just opposite अगर मैं आपको बोलूं कि if I give you x y and z, then how will you calculate r? So r will be root over x square plus y square plus z square. How you are getting these values? When you will add all the three equations 1 2 और 3 को square करके add कर दो. After squaring you have to add, then you will get the value of r. So value of r you will get, तो इसको आप इक्वेशन नंबर 4 पुट कर दो. ठीक है, फाई आपका कैसा आ जाएगा, पहले थीटा, आर के बाद हमेशा थीटा कैलकुलेट करना है ना, इसी सीक्वेंस में यू हैव टू राइट, सो दैट विल बी द गुड वन. सो थीटा इज नथिंग बट ए कॉस इनवर्स z अपॉन r, बट r क्या है यहाँ पे, एक्स स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर. सो ये आपका कहां से आया, इक्वेशन नंबर 3 से आया है ना. इफ वी वांट टू राइट द थीटा देन इट इज cos इनवर्स z अपॉन r, बट r इसलिए नहीं लिखा मैंने बिकॉज वी आर राइटिंग इन द टर्म्स ऑफ पैरामीटर ऑफ कार्टेशियन कोऑर्डिनेट सिस्टम. तो कार्टेशियन कोऑर्डिनेट सिस्टम के पैरामीटर्स क्या हैं, एक्स वाई और जेड हैं. तो राइट हैंड साइड में हमारे पास एक्स वाई जेड होना चाहिए और लेफ्ट हैंड साइड में वी शुड हैव आर थीटा एंड फाई. सो दिस फाई इज सेम tan inverse y upon x. So this is the three equations. So whenever you want to calculate r theta and phi, if you want to calculate the different coordinates, then you can use these three equations. अब आ जाते हैं अगेन, किसी वेक्टर को ट्रांसफॉर्म करना है. सपोज आई हैव ए वेक्टर ए, है ना. इस वेक्टर ए में मेरे पास आर दिया हुआ है मुझे, ठीक है. आर के बाद मुझे दिया हुआ है थीटा कंपोनेंट भी दिया हुआ है, ओके, एंड फाई कंपोनेंट भी दिया हुआ है. सपोज मेरे पास एक जनरल इक्वेशन है, थीटा थीटा और ये फाई. ओके, नाउ मेरे पास ये तीन कोफिशिएंट दिए हुए हैं एंड अगेन आई एम सेइंग कि यार लेट्स कैलकुलेट द vector in the Cartesian coordinate system. So how will you write the vector in the Cartesian coordinate system in this case? Okay, how will you write the vector or coefficients in the or matrix in this particular case? So again आपको use same करना है ना. यहाँ पे आप लिखोगे ax और ay और az, ये आपको कैलकुलेट करना है. एंड वी हैव ar, a थीटा एंड a फाई, ये तीन मेरे पास हैं. ठीक है, अब मुझे यहाँ पे क्या लिखना पड़ेगा, यहाँ पे मुझे लिखना होगा वी वांट टू राइट द वैल्यूज ऑफ दिस एंगल टर्म. एंगल टर्म क्या है, इक्वेशन नंबर 1 में साइन थीटा कॉस फाई. सो यहाँ पे आप क्या लिख लो, साइन थीटा कॉस फाई. फिर यहाँ पे आपके पास क्या है, साइन थीटा साइन फाई, ये लिख लो. फिर यहाँ पे आप लिख लो कॉस थीटा. फिर इसके बाद वाले में क्या लिखोगे, थीटा के रिस्पेक्ट में इसको डिफरेंशिएट कर दो, तो आपको मिल जाएगा कॉस थीटा कॉस फाई. यहाँ पे डिफरेंशिएट किए क्या मिलेगा, कॉस थीटा साइन फाई. यहाँ पे डिफरेंशिएट किए विद रिस्पेक्ट टू थीटा तो क्या मिल गया, माइनस साइन थीटा. अब यहाँ पे फाई के रिस्पेक्ट में डिफरेंशिएट कर दो तो माइनस साइन फाई. सिर्फ फाई कंपोनेंट को डिफरेंशिएट करना, सो साइन फाई को डिफरेंशिएट करोगे कॉस फाई आ जाएगा, और यहाँ पे फाई कंपोनेंट नहीं है तो डिफरेंशिएट करोगे तो जीरो आ जाएगा. ठीक है, सिमिलरली है ना. अब सिमिलरली आप ऑपोजिट भी कर सकते हो, है ना. आपके पास अगर ए आर ए थीटा और ए फाई कैलकुलेट करना है, अगर मान लो आपको, है ना, सपोज यू वांट टू कैलकुलेट ए आर ए थीटा एंड ए फाई, देन what will you do? Again, yes, absolutely right, we will calculate the transpose of this. So let's write sin theta cos phi and cos theta cos phi and minus sin phi. Then it is sin theta sin phi cos theta sin phi and cos phi. This is cos theta minus sin theta. Okay, so in this way you can convert a vector from one coordinate system, that is the spherical to Cartesian or Cartesian to spherical. Clear? This is nothing but a spherical to Cartesian, and this is Cartesian to spherical. Okay. So this is all about the basics of the coordinate system where I discussed the three different coordinate system, the parameters which are used in the coordinate system and their relationship with each other. So in the next class, we will understand more depth of this coordinate system, that is about the differential length. How do you write the differential length? What is the significance of this differential length? Differential surface, differential volume, all these in all the three coordinate system which we are going to discuss tomorrow at the same time 9 p.m. So we are actually continuing with our saga, success saga, that is we are bringing the most of the result. When you download our app, you will see there are multiple free sessions. There are very good session you will see with the animation also. The by that you will your understanding will be excellent, superb. So that means okay. So after that, we will say that All India rank 50, under 50 we have 62 students, All India rank 10, under 10 rank we have 13 students, under 100 we have 107 students across the branch, and they are our top rankers, 5 rank, first rank, and the fourth and fifth rank in the EE and IN. So thank you for watching this session. Don't forget to download the BYJU'S Exam Prep app because there is already free session running on the topic Laplace transform. Signals and system को अगर आपको learn करना है from the basic, then I am running one series in the app that is free of cost to all of you. Just you have to register in the app, download this app. You will see multiple free sessions. You will get the scholarship test also. You will get the free workshop also. So download our BYJU'S Exam Prep app from the Play Store and be a part of this BYJU'S family. Then you will see the difference in your concept, the difference in your understanding by the team of BYJU'S. Okay, so don't forget to subscribe the channel if you have not subscribed. Don't forget to join this Telegram group because you will get all the notification in this Telegram group, and there are separate channel Telegram group and channels for the separate faculty. So you should join all those Telegram groups also so that maximum students or PDF of all the classes and the daily questions you will get in this particular groups. Okay, thank you. Good night. Take care.